Hello my dear students, welcome back to our channel Madan Physics YouTube channel. நான் உங்கள் மதன் குமார் physics teacher. So இப்போ today இன்னைக்கு இந்த கிளாஸ்ல என்ன பார்க்க போறோம் அப்படினு பாத்தீங்கன்னா yesterday ஓட continuation தான் 12th physicsல problem 1.1 example 1.1 and Coulomb's law பார்க்க போறோம். And then very important Coulomb's law ஓட important aspects என்னென்ன அப்படிங்கறத ஒரு 7 points இருக்கு. அதை இன்னைக்கு பார்த்துடலாம். Okay? So வாங்க வீடியோக்குள்ள போயிடலாம். அதுக்கு முன்னாடி இன்னொரு விஷயம், நேத்து கிளாஸ் really I enjoyed. Most of the people they are given good comments, so thank you very much. So இன்னும் நிறைய பேர் என்ன பண்ணணும் அப்படின்னு பாத்தீங்கன்னா உங்க ஃப்ரெண்ட்ஸ் எல்லாருக்குமே மறக்காம ஷேர் பண்ணுங்க. நம்ம வீடியோவை ஸ்கிப் பண்ணாம ஃபுல்லா பாருங்க. It will be very useful to everyone, right? For all the 12th standard students. So thank you students. So இன்னைக்கு நம்ம பார்க்கலாம் problem. Okay? So problem 1.1 என்ன கொடுத்திருப்பாங்க அப்படினு பாத்தீங்கன்னா (1.1) that is example 1.1ல என்ன கொடுத்திருப்பாங்க அப்படினு பாருங்க. Calculate the number of electrons in 1 coulomb of negative charge. Calculate the number of electron. Okay, calculate the number of electrons in 1 coulomb of negative charge. Adha நம்ம calculate பண்ணனும், number of electrons. But we know the quantization of electric charge equation, Q is equal to NE, right? Q is an charge, N is an number of electrons, E, we know the value for E, electric charge, that is 1.6 into 10 power minus 19 coulomb. That we know very well, isn't it? So in this equation we should derive the value of N equal to Q by E. So already they are given in a 1 coulomb of charge. Charge means that is Q, 1 coulomb. They are given in the textbook. Okay. So N is equal to 1 by, what's the value of E? 1.6 into 10 power minus 19. Okay. 1 divided by 1.6. How much? 1 by 1.6. This 10 power minus 19 can take up now. What we are getting into 10 power plus 18. Isn't it? So this is 0.625 into 10 power 18 will come. After that 1 point for this. Okay. So therefore 6.25 into 10 power, this minus 19 will go for like this, means digit, 1 digit. Okay, 10 power 18. Okay, that is number of electrons. Number of electrons. This is the problem. Okay, so if you have any doubt, just you see to this, very important. Okay, so for this one more question also. Next, for a very important topic in our public examination, it will be too important for all the time. Okay, for in all the question paper, it will be very important. So what is that means? That is Coulomb's law. Coulomb's law. So what is meant by that Coulomb's law, sir? Coulomb is the name of the scientist. Okay, so that is the name of the scientist. Just you listen what I thought. Okay, see, consider any 2 points. See here plus Consider any 2-point charges, like this is Q1 and this one is Q2. Okay, so the distance or this is 2-point charges Q1 and Q2. The distance is R. Distance is R. For this unit vector, that is R cap, 1 to 2. 1 to 2. Okay, Q1 to Q2 அப்படிங்கிறதுனால 1 2 போட்டுக்கிறோம். ஓகேவா? So the force exerted opposite to the direction, that is F vector 2 1. F vector 2 1. So what we are going to discuss here, Coulomb's law. So consider 2-point charges. Listen carefully. Consider 2-point charges Q1 and Q2 at rest. Consider 2-point charges. Understand? 2-point charges Q1 and Q2 at rest in vacuum. Rest in vacuum. And separated by a distance r. And separated by a distance r. Okay. So these two charges are separated by a distance r. According to Coulomb's, the force on a point, according to Coulomb, the force on the point charge Q2 exerted by another point charge Q1. According to Coulomb, the point charge, the force on the point charge Q2 exerted by another point charge, which one? Q1. Okay. So how can we form the equation F vector 2 1. Keep your mind. This is equal to K. Q1 Q2 by R square R cap 1 2. R cap 1 2. Okay. So here R cap 1 2 is an unit vector. R cap 1 2, that is unit vector. Unit vector directed from charge. Directed from charge where to where? Q1 to Q2. So that's why we are putting like this 1 to 2. Okay. So students, so R vector, that is R cap 1 2 is a unit vector directed from charge. Directed from charge. Which one to which one? From charge Q1 to Q2. Q1 to Q2. Understand? So after that the K. What is meant by K? K is a proportionality constant. K is a proportionality constant. Okay, so students, this is the Coulomb's law. Okay, so keep your mind. So also we can derive. How can we derive the formation? Okay, like the force of attraction or repulsion between 2-point charges is directly proportional to. See, when we are take this constant means, how can we form the equation? Just I am writing F is directly proportional to Q1 Q2 by R square. Like this, simply we have to represent to form the statement of Coulomb's law. Okay. So how can we define the Coulomb's law? Means the force of attraction. Coulomb's law states that the force of attraction or repulsion, it may be, okay, attraction or repulsion between 2 point charges is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. So we can also write the formation of equation F is directly proportional Q1 Q2, F is inversely proportional to distance of the square. We can write these two equations. This is formation. Okay, so simply we are writing like this. Okay students, next topic, what is that importance aspects of Coulomb's law? See, important aspects of Coulomb's law. Okay, so first point. So what is the important effects of Coulomb's law? If they are given 7 points, okay, 7 points. This is one of the most important 5-mark questions. You should keep a very constantly, okay. So ரொம்ப முக்கியமான ஒரு விஷயம் என்ன அப்படினு பாத்தீங்கன்னா, இந்த கூலம்ஸ் லாவுடைய இம்பார்ட்டன்ஸ், முக்கியத்துவம் அப்படினு சொல்லுவோம். சோ அந்த ஒரு முக்கியத்துவம் பாத்தீங்க அப்படினா இருக்கிற அத்தனை பாயிண்ட்மே ரொம்ப மேஜர் பாயிண்ட்ஸ் தான். ஓகேங்களா? சோ நான் என்ன சொல்றேன் அப்படிங்கறது you have to be concentrate. Okay, keep concentrate, watch fully, நல்லா லிசன் பண்ணுங்க. ரொம்ப பொறுமையா ஒவ்வொரு பாயிண்ட் எப்படி வந்தது அப்படின்னு எக்ஸ்பிளைன் பண்றேன். சோ as it is நீங்க புக்ல இருக்கிற மாதிரி, டெக்ஸ்ட் புக்ல இருக்கிற மாதிரி நீங்க படிச்சீங்க அப்படினா you won't be understood that fully. Okay, நான் என்ன சொல்றேன் அப்படிங்கறது just you take down the notes also, so no problem for that, right? So listen carefully. So first point, Coulomb's law ஒண்ணும் இல்ல. first pointல என்ன கொடுத்திருப்பாங்க அப்படினு பாத்தீங்கன்னா, simply I'm saying from the equation, I'm already told you F is directly proportional Q1 Q2 by R square. Okay, இதுதாங்க first point. So என்ன சார் இருக்கு அதுல? first pointல அப்படி என்ன இருக்கு? F னா நமக்கு தெரியும் force, Qங்கிறது charges, Rங்கிறது distance, அவ்வளவுதான். ஓகே, சோ இத நம்ம என்ன பண்றோம் அப்படினு பாருங்க. இது ஒரு பாயிண்டா கன்சிடர் பண்ணுங்க. Q1 ன்னு வெச்சுக்கோங்க. இங்க Q2. இது ஃபோர்ஸ், அவ்வளவுதான். சும்மா ஜஸ்ட். ஓகே, சோ இந்த ரெண்டுத்துக்கும் பிட்வீன் பாத்தீங்க அப்படினா ஒரு பாயிண்ட் O அப்படின்னு கன்சிடர் பண்ணுங்க. ஓகே, சோ இப்போ இத வந்து இதோட டிஸ்டன்ஸ், இங்க இருந்து ஒரு R, இங்க இருந்து ஒரு R. சோ அப்போ டோட்டலா பாத்தீங்க அப்படினா R into R, R square. ஓகே, இது வந்து இந்த ஈக்குவேஷனுக்கான டயகிராம். சரிங்களா? சோ இப்போ இந்த ஈக்குவேஷனை how can we modify அப்படினு பார்த்தோம்னா, F directly proportional Q1 Q2, F inversely proportional 1 by R square அப்படின்னு எழுதலாம் இந்த ஈக்குவேஷன். சோ ஃபர்ஸ்ட் பாயிண்ட்ல என்ன இருக்கும் அப்படினா இதுதாங்க இருக்கும். சோ இத வந்து என்ன பண்ணிருப்பாங்க, வேர்டிங்ஸ்ல கொடுத்திருப்பாங்க. ஓகேவா? சோ நீ இந்த விஷயத்தை அங்க நீங்க புக்ல, டெக்ஸ்ட் புக்ல நோட் பண்ணணும். அப்படி பண்ணீங்க அப்படினா it will be very useful to for when we are going to go through that, right? Force is directly proportional to this two charges are product. Okay, this R, that is R square, is in a distance that we know very well, right? So how can we form the statement for Coulomb's law? Coulomb's law states that the force of attraction or repulsion between 2-point charges, that is very important. Okay, so Coulomb's law is very important, very most applicable for that point charge only. Okay, so force of attraction or repulsion between 2-point charges, that is directly proportional to product of the charges. Force of attraction or repulsion between that is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. That is first point. Okay, keep your mind. Second point, the force on the charge, the force on the charge, Q2 exerted by the charge Q1, exerted by the charge Q1. So the force on the charge Q2 exerted by the charge Q1. Q2 மீது அந்த சார்ஜ் வந்து Q1 மேல விழுது. ஓகேவா? அப்ப என்ன ஈக்குவேஷன் வரும் அப்படினு பாத்தீங்கன்னா, that is இதுல r cap 1 2, that is unit vector, that you know very well, right? Unit vector pointing from charge Q1 to Q2, charge Q1 to Q2, r cap 1 2 அப்படினா சார்ஜ் வந்து Q1 to Q2 க்கு தான் போகும். அது வந்து நான் இதுக்கு முன்னாடியே உங்களுக்கு கூலம்ஸ் லா சொல்லியிருக்கேன் இல்லையா? சோ நெக்ஸ்ட் பாத்தீங்க அப்படினா the force, நான் எழுதி போறத மறக்காம you should take down the notes. So the force on the charge, now Q1 exerted by, okay, so Q1 exerted by the charge Q2. So how can we form this R cap? That is, now see that opposite, isn't it? Q2 exerted by the charge Q1 means R cap 1 2. Q1 exerted by the charge Q2 means that is opposite, right? So that is minus of R cap 1 2. That's the thing. So that is because direction opposite to R cap 1 2, R cap 1 2. Okay, so this is the second point. Okay, keep your mind. So next, third point in SI units, textbook la paathute vaanga, in SI units பார்த்தீங்க அப்படின்னா they are given one value for K is equal to 1 by 4 pi epsilon naught. Okay, so students, please listen. This epsilon naught அப்படிங்கிறது permittivity of free space in vacuum. Permittivity of free space. Okay, so the value of this epsilon naught is 8.854 10 power minus 12 Coulomb square Newton inverse meter power minus 2. Okay, so after that the total value of this K 1 by 4 pi epsilon naught is 9 into 10 power 9 Newton. 9 into 10 power 9 Newton meter square Coulomb power square. Okay, so that is a thing. So next, now how can we derive the value of epsilon naught? Now see that K is equal to what? 1 by 4 pi epsilon naught. I need the value of epsilon naught now. Epsilon naught is equal to K. We are going like this, means 1 by 4 pi K, right? So this value 1 by 4 pi K, that is epsilon naught. This is the epsilon naught value. 1 by 4 pi K value is this. Okay, that is, keep your mind. So this is the point 3. Third point. Next, fourth point. So what they are given in the textbook, see, just you listen. Fourth point, the magnitude of the electrostatic force are correct. The magnitude of the electrostatic force correct or wrong, right? So electrostatic force between two charges they are given in the textbook. Two charges, each of 1 coulomb, right? So, and the distance 1 meter and distance 1 meter. Distance 1 meter, two charges each of 1 coulomb. Okay, so Q1 and Q2 is 1 coulomb, R is 1 meter, like that only, right? So how can we form this? F is equal to 1 by, so from the beginning we have formed the equation F is directly proportional Q1 Q2 by R square. This is simple equation for the Coulomb's law. Okay, so when we take the directly proportional to, we want to put one constant equal to and constant K Q1 Q2 by R square. So we know the value of K is 1 by 4 pi epsilon naught. Okay, so how can we modify this equation? F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. Okay, so F is equal to 1 by 4 pi epsilon naught. We have the value, right? In third point itself, we have the value. What is the value? 1 by 4 pi epsilon naught value 9 into 10 power 9 Newton meter square Coulomb power square, right? So you have to substitute the value here, 9 into 10 power 9. Q1 Q2 1 Coulomb 1 Coulomb, 1 into 1 divided by 1 square, that is 1 only. So F is equal to 9 into 10 power 9. So 1 divided by 1. This came 1 by 1, 1, 1, 1. So into 1 only. So F is equal to 9 into 10 power 9 Newton. Okay. So this is the point number 4. Okay students, if you have any doubt means just you see to this. Okay, so we can change the charges value also. Here they are given 2 Coulomb means we have to put here 2 into 2 divided by 2 square 4. Okay, so whatever it is, கொஞ்சம் ஒரு listen பண்ணுங்க, என்ன மேட்டர் அப்படின்னு பாத்தீங்கன்னா, ஒரு இங்க என்ன கொடுக்கறாங்களோ சார்ஜோட வேல்யூவும் டிஸ்டன்ஸோட வேல்யூவும் சேமா இருந்தா, ஒரே மாதிரி இருந்துச்சு அப்படின்னா நீங்க கண்ணை மூடிக்கிட்டு இந்த வேல்யூவை போட்டுடலாம். நீங்க சார் டிஸ்டன்ஸ் சார்ஜோட வேல்யூ Q1 Q2 10 கொடுத்திருக்காங்க, டிஸ்டன்ஸும் 10 தான் கொடுத்திருக்காங்க அப்படின்னா 10 into 10 100, அப்படியே 10 square 100 தான். சோ அப்போ 1 தான் வரும் ஆன்சர். சோ அப்போ for 9 into 10 power 9 தான் Newton. Okay, so whatever it may be, they are given in the same for charges value and distance value. The answer is 9 into 10 power 9 Newton only. So no need to change over that, right? So if they are given change in that charges value and distance value means it will be change the force value. Okay, so keep your mind, it will be very useful for 1 mark. That is very important. Okay, so இப்போ point number 5 பாத்தீங்க அப்படின்னா, so அதே மாதிரி தான் SI யூனிட் தான் கொடுத்திருப்பாங்க. SI units Coulomb's law in vacuum. Coulomb's law in vacuum. So அப்படி பார்த்தோம் அப்படின்னா takes the form in vacuum, takes the form. So how can we form the equation for Coulomb's law in vacuum? That is F vector 2 1. F vector 2 1. This is equal to, we know very well the equation 1 by 4 pi epsilon naught Q1 Q2 by R square R cap 1 2. Here 2 1 means here R cap 1 2. So there is no value for this because this is a unit vector. Okay, so in a medium of permittivity, in a medium of permittivity, that is epsilon. First you understood epsilon is a permittivity of medium, epsilon naught is the permittivity of free space, epsilon r is the relative permittivity. Okay, so keep your mind. So these are the very important for this. Okay, so F vector 2 1 is equal to, because we have the equation already like this, when we have to change over the permittivity of medium. So how can we form the equation? So that is F vector 1 by 4 pi epsilon. Okay, so no need to forget to put epsilon naught. Epsilon naught அப்படினு போட்றாதீங்க. epsilon naught க்கு பதிலா தான் we have to change over that permittivity only. Okay va? So we can form the equation for medium of permittivity, that is epsilon. Okay, so epsilon naught, we have to change epsilon as it is remaining equation, right? Q1 by Q2 R square R cap 1 2. Okay, so since I am writing here, listen carefully. Since epsilon is greater than epsilon naught. Okay, epsilon is in medium, epsilon naught is in, what is that? Vacuum. Okay, vacuum. So here we define the relative permittivity. Here we define relative permittivity epsilon r for epsilon r is equal to epsilon by epsilon naught. Keep your mind, epsilon r is equal to epsilon by epsilon naught. So for a vacuum or air, this is very important one more. Keep your mind, students. What is the value? Epsilon r is equal to 1. The relative permittivity where is the value equal to 1 means air or vacuum. Air or vacuum. Okay, so epsilon r is greater than 1 where means in all other media, all other medium. Okay, rare medium, denser medium, like that, such type of mediums for epsilon r is greater than 1. So this is a very important point for aspects of Coulomb's law in point number 5. Okay, so next point number 6. So please take down the notes. Just take a book. I would like to explain because why I take a book means so many underlining words will be there. Okay, so just you take down, underline that everything. Okay, see, first one, that is Coulomb's law. Second, the gravitational force between two masses is always attractive, but a Coulomb force between two charges can be attractive or repulsive depending on the nature of the charges. That you know, both points are very easy only. Okay, so next we know the variable for a gravitational constant value. What is that value? 6.626 into 10 power minus 11 Newton meter square kg power minus 2. Okay, so that is gravitational constant. The value of constant K in Coulomb law is, we know the very well, Newton meter square Coulomb power minus 2, isn't it? So next, the gravitational force between two masses, so they are given in the value of mass value, and after that both forces. See, the gravitational force between 2 point masses in the same, whether two masses are at rest in motion. Okay, so if the charges are in motion, that is called like a Lorentz force. Okay, so another force is Lorentz force. So come across the plane in additional Coulomb forces. So after that, seventh point, it's very important for seventh point. number 7, what they are given. See, for 7th point என்ன சொல்லியிருப்பாங்கன்னா, so the force on a charge, the force on a charge Q1 exerted by a point charge Q2. Point charge Q2 is given by F vector 1 2, that is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square R cap. Here 1 2 means here 2 1. Okay, that keep your mind. So here R vector 2 1 is a unit vector. Is an unit vector from charge Q1 to Q2 or Q2 to Q1. Q21 means Q2 to Q1. Okay, so but R cap 2 1 is equal to minus of opposite R cap 1 2. That you know very well, isn't it? So we have to substitute the R cap here. This value you have to substitute here, and to form the equation F vector 1 2 is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square minus of R cap 1 2, right? So after that we have to form the equation is F vector 1 2 is equal to minus of, that is very important, you have to multiply the minus 1 by 4 pi epsilon naught Q1 Q2 by R square Q1 Q2 by R square R cap 1 2. From this equation we have to find the value of force is opposite to the direction. See, F12 F12. So F12 F vector 1 2 is equal to minus of F vector 2 1. Okay, so this is the thing. If you have any doubt, you can make comment in my comment box. Okay, so next class we will see some most important topics. Okay students, so today class is over. Okay, so thank you very much. Share every one of your friends. Read well. Thank you.